Thank you very much for introduction to invite us to make the presentation here regarding processing of polyketone with hot runner systems. My name is Jörg Essinger, and I work for Günther Hot Runner Systems since 2004, and I'm responsible for the application technology department. After my university time, I started also with the former Höchst AG, later then Celanese, and I was a colleague of Mr. Wied. And yeah, since 2004, I work with hot runner systems and the different kind of polymers. So we not only process thermoplastics, we have also special biopolymers, feedstocks, also LS systems for liquid silicon rubber. So we have a bright range for products. Some words. No. Some words for our company. Company Günther Hot Runner System was founded in 1983 in a barn, as you can see here on the left-hand side. Mr. Günther itself is here in his workplace to develop and to produce the first nozzles. They have a small old Arburg injection molding machine to carry out the first tests. And his philosophy was and is you could make a mistake at only one time. And then they have to improve it. And yeah, for this, he developed more and more better systems. Now we have approximately 200 employees, and we assembled or we manufactured hot runner nozzles in the different sizes and kinds, manifolds, also so called hot halves, as you can see here. And we are located in the middle of Germany or in the middle of Norway, north, between city Kassel and Marburg. And it's also a nice region to come to make vacation with us. So you are invited to come and visit us. But we are also all over the world where also our customers are. So we have our own subsidiaries in different European countries as well as in the Far East region and also in North America. Yeah, as you heard or saw, polyketone grade is launched in the market in 2015. And now you will find different kind of grades by distributors like KD Feddersen or with other compounders like Acroplastic or Ems Chemie or Ria Max or Lyndall Basel. And you saw also the wide range of properties and the good constellation of this material. And for this, we see that more and more customers ask also for hot runner systems to process the polyketone grades for their applications. In the beginning, I remember in 1998, we heard from Thomas Carillon, maybe some of you remember. This was really terrible to process, and for this Carillon was cancelled after a few years from the market. And we wonder that Duzong will come again with a polyketone, and we are really surprised how will be the processing of the material. And of course, polyketone could be processed with hot runner systems. It's a quite challenge, but it's a solvable task to, if you take care on special issues, as you can see here. The main issue is residence time and temperature. It's a very, very important issue for this material. Also, you can see here maximum temperature in the hot runner between 240 to 160 degrees Celsius. Our test showed that the mold temperature does not have so much influence on the possibility of the material regarding cross-linking or degradation. And also very important is that the injection unit, that the hot runner system is really clean. So when you start with polyketone, everything has to be cleaned, that you have a real metal blank surface. If there are some rest of nylon or POM inside, you will never have fun with this material. So take care on it to have everything very, very clean. What is the function of a hot runner system? Maybe you know it, but I will summarize this. The function of the hot runner system is to bring the sufficiently plastified melt from the injection unit into the cavity. Please have in mind, the hot runner system is not a water heater, that the melt flows through the hot runner, and during this time, the melt is heated up. This does not work. So the melt has to be prepared sufficiently in the barrel, in the injection unit. This is very important. And the function of the hot runner is to maintain the molten liquid situation of the melt. And the second issue is, that the pressure loss is quite less and the residence time is not too long. And between these two issues, we have to find a compromise regarding the dimensions of the melt channels, lengths, and so on. As you can see here, no, it's not wrong. No. One of our customers in Italy came in 2016 and asked, is it possible to process polyketone with hot runner? With the experience from the former Carilon, we said, no, not really, but send us a new material, we make tests. We have a laboratory with 4 injection molding machines with different kind of test molds, so we are able to carry out a lot of tests with our hot runner system. And if you are interested, come to us and we could carry out tests together with you with your polyketone crate to see if the process will be okay or not. In this case, we carry out the test. You see here one of our test molds with a disc as a sample part. We use here a hot runner nozzle with an open tip. And we have here also a special heating element inside, which fulfills a very good, unique temperature profile inside of the nozzle. So we have to check how is it processing the temperatures, how is the filling study, and also what happened after process interruptions, about 5, 10, and 15 minutes. And the results showed, okay, with this polyketone crate, it is possible to realize a project to process the material without big problems, but we have also to take care. Residence time more than 15 minutes are really critical due to cross-link behavior and then degradation. And it's also very, very important to purge the barrel as well as a hot runner system with a very high viscosity polyethylene or propylene. Please also take care. The viscosity has to be really high, MFI from approximately 1 or less at 190 degree and 2.15 kilogram. Otherwise, you don't have a good purging effect in the system. This was our first hot runner system, which we realized with a polyketone in 2017. This was a PK crate with 10% glass fibers, 6 grams per nozzle. And we have here a 2-drop hot runner system. You see here the nozzle tip. And this mode is always running as I know till today without any problems. What is now special with our hot runner system? As you can see here on this picture, we have the hot runner nozzle here. We have here the heating element. This is so-called blue flow heater or thick film heater. It's developed by ourselves and we produce a heater also in our house. Around this heating element there's a material tube. We have here a two-part shaft. This area of the shaft is out of steel. This one here is out of a special titanium alloy with a very low heat conductivity. And between shaft and heating element, there is an air gap. You know, air has a very good heat insulation behavior. And the contact between nozzle and mold is far away from the hot area of the tip. You can see it here. We have here the nozzle in a sample situation. Here is the contact between the titanium alloy and the mold. And here we need the heat. And you could imagine, due to this, we have a very low heat loss. You can see it here also in the low arrows, the flow of the heat, the long way across a material with low heat conductivity means we have a very low heat dissipation, and the heat you don't lost, you don't bring it back into the hot runner nozzle. This is influenced also the temperature profile inside the nozzle. And this is one of the, let me say, most important issue. On the right-hand side, you see a nozzle of one of our competitors. We measured the temperature inside the nozzle. We fill the nozzle with plastics, assemble the nozzle in a mold, heat the nozzle up to 300 degree, mold 30 degree, and then we measured with a separate thermocouple to the manifold into the nozzle, the temperature inside the plastic, and then we see this temperature situation inside the nozzle. On the controller, you have 300 degree. Maybe you know what happened in the hot runner itself. Here you see, we have 50 degree more. And you could imagine this polyketone, it's not so recommendable, such a temperature situation on this material. Maybe with a polypropylene, it could work, yes, but not with polyketone. With our nozzle and with our friction heating element, we have such a temperature profile. We have the same measurement system. And you see here, we are only approximately 10, 15 degree more. Here in this area, we have more power to bring enough heat into the area of the tip. If you are interested, I have here such a heating element, and you could see, or maybe also not, here in the front area, close to the tip, we have very high power density, 55% approximately of the complete heating power to have enough heat into the gate area. In the middle, we have only 22 or 20% of power due to there is no heat leakage or a heat loss. And on the backside, close to the manifold, we have a little bit more heat necessary, and we could adjust the density of the power as we need. Due to we produce the heating elements also in-house, so we have a high flexibility to produce such special heating elements. So if you are interested, you could have a look on it later. What kind of injection points or injection gating we have? This is a standard one, open nozzle with a tip. We have here an open nozzle with a straight hole in the middle, and we have the valve gate systems. It is also important to know regarding the processing of polyketone. As I mentioned before, temperature distribution is very important for polyketone. We have checked also the manifold. You see here a manifold with 16 nozzles, and before we make a heat simulation, and you can see on the right-hand side the difference between maximum and minimum temperature of the manifold is 3 Kelvin. We produced this manifold, we added a lot of thermocouples around the manifold to measure the temperature during the process, and the difference in reality is approximately 5 Kelvin. So we have here also a very good heat distribution, a very unique temperature profile inside the manifold, which is also important for the polyketone processing. In our house, we have a database where we add applications with customer, also add the results of our own tests. And we have more than 100 data files inside this database for polyketone. So you could see that we have a lot of knowledge and experience with this kind of material. Here you see an application which we realized in 2018. This is a polyketone crate with 30% glass fibers and flame retardant in combination with a very nice color orange. For high voltage connection for the e-mobility, and here it's used in the first step, open nozzle with tip. It's a 4 impression of 4 drop hot runner systems and molded by a sub runner for an 8 impression mold. Here we have the problem that due to the residence time, materials start to cross-link. And then with the situation we have here with a tip, we have only a small flow gap. Cross-link material could not purge out. Then you have a blocked gate, and you have to disassemble the complete mold to clean everything, and nobody wants to this. This was also a customer who did not understand to use a polyethylene with a high viscosity. I have a polyethylene in my stock, this is okay. No, it's not okay. Yeah, he makes experience, that's all. Then we modified the nozzles to an open tip with one big hole in the middle. Then you have a chance. If you have a crosslink, you could purge out the cross-linked material, the solid material, and you don't have the problem to disassemble the complete mold for cleaning. Here, a similar application, same material. In this case, the molded part with metal is put in a mold and then is over molded again. And here you see the subrunner. So the part is injected from the both sides. And we have here also a 4-impression hot runner or a 4-drop hot runner system for a 2-impression mold. We have here 300 gram per nozzle. So this is a really big volume for this application. And here we also started directly with an open nozzle with a hole in the middle. And this process is now running since 2020. We also realized applications with valve gate system. Here we have a material polyketone unreinforced. It's a polycetone grade in this case, 1 gram per nozzle. Here we have a nozzle. We have a nozzle 6 means the diameter. Internal is 6 millimeter. The N means valve gate system. You see here the valve pin inside the hot runner nozzle. Regarding the design of the hot runner nozzle, it's the same like the open one, also with a good heat distribution. But instead of the tip, we have here a separate needle guide. And the needle is guided or pre-guided in this area, and then it's closed here, the gate point, directly in this needle guide. So we have the advantage if the gate point is worn, we have only to change the special mold insert part and not to prepare the whole mold insert with welding and grinding and so on. We have here as a needle drive, single cylinders, so each needle has 1 cylinder. This is also recommended by Polyketone. If you use needle valve systems, you have to take care that if, for example, one nozzle is blocked, that you switch off the other 3 ones, that you can bring the whole pressure of the machine to the one nozzle which is blocked to purge out the solid or the cross-linked material. So it makes sense if valve gate system to use such single valves for the needle drive. But take care, polyketone grades with flame retardant and orange. We never recommend to use the valve gate system. This does not work. One of our customers has such a system. He had a vertical injection molding machine, and he thought, I would have to use a valve gate system to avoid pulling out. He made 3 shots and everything, nothing was possible anymore. Due to the situation that we had only a flow gap over the length of the nozzles, it was not possible to inject the material. We had the cross-link situation, and the customer has to build a new one with an open system here with a straight hole in the middle of the nozzle. And after they modified the mold with this new hot runner system, the process is running. And there's also no problem with swirling out, even when they have the vertical injection molding machine. So this polyketone with less fibers and the situation with flame retardant and orange, you have no problem with swirling out the material. But please have in mind, no valve gate system for flame retardant and orange grades. Here is another application. This is a 16-impression mold with an 8-drop hot runner system, also by a subrunner. We have here the manifold, which is fully balanced. We have two heat control zones on the manifold to have more flexibility to the better temperature situation inside the manifold due to the radiation in the mold. And here we have also an open nozzle, an open nozzle with a straight hole due to the injection on a subrunner. And this mold is also running well since some years. As a summary for our experience, we have now since approximately 10 years. First, we would say, when you have to realize a project, please involve the material supplier as well as the supplier of the injection molding machine. You saw this from Mr. Wiet. Arburg has also a lot of experience with the processing of this kind of materials, also Engel. So yeah, it makes sense to bring all participants on one table. The thermal separation is very important, that the heat is inside the hot runner and that you don't have too much heat loss to the cooled mold. It's very important to have a homogeneous temperature, as you saw, to avoid cross-linking situations inside the hot runner system. Sometimes it could happen that you have a cross-link situation, maybe when the residence time is a little bit too long, if you have a process interruption. For this, we recommend when you make a mold, take care that you could put the cavity plate from the mold on the moving half, that you are able to clean the gate area directly on the machine. This takes time, and it's when you make the design of the mold, it's a small effort, but later it's very, very helpful. When you inject through a subrunner, use the open nozzle with a straight hole in the middle. When the direct gating, of course, the valve gate system could be used, but not in combination with flame retardant and the colored orange. And in general, flame retardant grades with the color orange, it's quite critical to process. In our experience, we could offer 8 impression hot runner systems for unreinforced, glass fiber reinforced polyketone grades. It is also possible this polyketone grades is flame retardant between 4 and 8 impression hot runner systems, but with flame retardant and color orange, we recommend only to use 2, maximum 4 for hot runner systems. Otherwise, it's too critical to balance and to work with such a system. You will not be happy with this situation. We also recommend, if you have an interruption more than 10 minutes, purge with polyethylene. So I know some customers have a special system. If there is a process interruption, the material Zuführung changes from polyketone to polyethylene. Then they have automatically programmed that the unit and also the hot runner is purged with polyethylene, and they don't have any problems. This is really helpful. Also, before you switch off the system, or purge with polyethylene or polypropylene, and never shut off the hot runner system when polyketone is inside. You will have big problems to clean it. With polyketone, you could not use thermal cleaning. You have to clean it mechanically, careful with a drill, and it's not really nice to do this. One of our customers told us they, for example, purged the system twice a week. And with this situation, he could run the molds, the machine, more than half a year without any problems for blocking or black specks or such things. So this could be also a good recommendation for continuous purging with high viscosity polyethylene. As I mentioned before, when you realized projects, it's important to bring all participants on the table. As you can see, the hot runner system is only a small part of the complete system. But when the hot runner does not work well, you have always a problem with the whole process. And for this, we ask, come together, invite each one to realize a project without big problems. As I also invited you, if you are interested, we could make material tests in our laboratory. We carry out these items, as you can see here. And if you want to know more about our hot runner systems, we invite you also to come to our booth here in Hall 1, booth C44. Then you could see also more hot runner components. I have also here 2 nozzles here in front of me. So if you want to see this also and to take it with your hands, you are welcome. And many thanks for your attention. And if you have any questions, don't hesitate to ask. Thank you.
Thank you for the great information and technology. Before closing this section, do you have any questions, guys? Actually, I have it. If you can answer to me.
Yeah, of course.
May I ask a question? I just write down and give you the question. A little bit long. So I saw that it seems important to maintain the hot runner temperature consistently between 280 C and 300 C. The page, the computer one and your one.
So this page.
This was the comparison of your nozzle and the completed nozzle.
Okay.
Long.
Yeah.
The length of the nozzle.
Okay. For us, we defined to make the temperature profiles at a temperature of 300 degrees. Only to have a compare the temperatures together. This is independent for the processing of polyketone. So it's only to show how the temperature situation is inside the nozzle.
Inside.
Yeah.
Because my question is that.
Yeah, right. Yes, we use polypropylene, put it inside, and then we measure the temperature inside the polypropylene.
Okay. So that's not for polyketone, right?
No. This is only to show how the temperature is inside the hot runner nozzle.
Polyketone degraded temperature,
Of course.
about 300 volts.
Yeah, of course. Thank you. Hier haben wir noch so eine Nozzle mit zweigeteiltem Schaft. Also wen es interessiert, steht hier vorne. Hier haben wir nochmal die entsprechende Dickschichtsheizung. So wie so. We have here the nozzle in the 2-part shaft. If you want to show this here and also the heating element. Different heating elements which we recommend to use also for the polyketone processing. And we have also a flyer, so if you want to get more information, feel free to take it.
Actually, in my opinion, this information is very helpful and great information to enlarge polyketone world larger and bigger. So today our POK seminar has been coming end, and lastly, anybody have questions or comments or something? Any other idea do you have? Okay, please.
So at the beginning of the very nice presentation, you showed that the material get yellow, no? Color when you expose the material to heat and moisture. And so that's not related to degradation, or why is this happening? And if the mechanical properties are affected by this yellowness.
The discoloration occurred in only the surface. If you look at the inside of the specimen or part, then no change. So it means that the overall properties cannot impact the our mechanical strength. It is the same. Yeah, some application like fitting in the coffee machine, our part is change it to brown. If we measure the discoloration is around 40 to 50 micrometers, and inside no change. So mechanical performance is, we can maintain the mechanical performance.
Thank you very much for the answer. Anybody else? Okay, so maybe Mr. Chen. Okay, I think it's a great time to talk together. So please let us finish this pre-Keaton valuable seminar. And we have a plan for the next year. So next year we have Mexico exhibition. We make open a booth and pre-Keaton seminar. And next year Bakuma, we will make another pre-Keaton seminar. Hope we make better and bigger. Thank you very much. Now we can have just the free talking and networking together. Thank you.